Okay, well, let's kick off because we are going to end early today because there's some moon thing going on, which we want to have a look at. So welcome everyone to Zoom into Physics Part 2. Let me start by acknowledging the traditional custodians of all of the lands on which we're dialing in from. It's the Darug people where I am in DY. And pay our respects to their elders past, present, and emerging. And in preparation for this, I did look up what the moon means to the traditional people of Australia. Of course, there's a plethora of different answers to that with a nation so diverse. But in most of the Aboriginal cultures, it seems that the sun is a woman and the moon is a man because it starts off big and round and fat. and he's punished by his various wives who chop various bits off him, and that's why he gets smaller. So many different interpretations, lots of different stories as well. So we're here to talk a little bit about the moon today because we have something going on, a blood moon and a lunar eclipse tonight, just after 9. So we'll be stopping for that. And without further ado, I will ask our 3 panelists to introduce themselves. We have an experimentalist, a theorist, and a philosopher. So let's start off with Kirrily. Maybe you can introduce yourself briefly and tell us what intrigues you about the moon.
Thanks, Scott. So yeah, my name's Kirrily and I work at ANSTO, the Australian Nuclear Science and Technology Organisation. So I'm a neutron scatterer or a condensed matter physicist by trade. So I'm the experimentalist here. The thing that intrigues me most about the moon, I think, is the far side of the moon. I think it's always interested me that we can see the same face of the moon no matter how we look, but who gets to see the far side of the moon? You know, when I did some reading up about the far side of the moon, it's quite interesting to see how different it is from the near side of the moon and how there's an asymmetry to the moon, how these, you can see in this picture behind me, I do have to plug this picture. It was taken a couple of days ago by my good friend, Andy Casely. So this was taken in the Blue Mountains of our beautiful moon just a few days ago. But these dark spots that you see here, these Maria, these are sort of big plains on the moon. And what's interesting is that the people that have flown by the far side of the moon have revealed that these occur mostly on the near side of the moon, the side that we can see. Only about 1% of the far side of the moon is covered with these interesting plains. So the far side and the near side are really very different. And I think that is what intrigues me most about the moon.
Thank you very much, Kirrily. Let's move on to Geraint.
Okay, so yeah, my name's Geraint Lewis. I'm a professor of astrophysics at the University of Sydney. I study cosmology, so I'm interested in the sort of evolution of the entire universe. So, you know, where did the universe come from? Where did the universe go? Where is it going? One of the questions that I'm very interested in is about life in the universe. I study this notion of cosmological fine-tuning and aspects of our universe that allow life to be here. And so the bigger questions of life, not just across our universe, but across possible universes, different universes. And what's intriguing when asking this question is that it appears that our Earth is kind of weird. It's not a typical place in the universe. It's not a typical planet. It's not orbiting a typical star. And one of the things which is very weird when we look in our solar system, at least, is that our moon is not a typical moon. Our moon is very large compared to the Earth. And it wasn't just a rock that got captured. It's got an implicit history with regards to the Earth. And it's thought that the presence of this very large moon orbiting the Earth has played a crucial role in the stability of the Earth and the ability for the Earth to be habitable. So, I love looking at the moon. I didn't get to see it much as a child because I grew up in cloudy Great Britain. But every time I look at it, I do wonder about that role that it's potentially played in me being here to ask these questions.
Thanks, Geraint. And Tibor, tell us a little bit about yourself and what you love about the moon.
Scott, yes, my name is Tibor Molnar. I'm a philosopher of science at Sydney University, which means that I'm an armchair astronomer. I sit back and I think about what it all means. What fascinates me about the moon is the effect that it has on the Earth. It affects its orbit, the way it spins. But more interestingly, I find it really intriguing that coral, for example, know that they have to spawn on the night of a full moon. I mean, there are all sorts of interesting things that go on. There's even a suggestion that if the moon had not been manufacturing tides gravitationally on the Earth, then life would not have formed on the planet, because the only way to form polymers is on the coast of shores where the water comes in and goes out again. I went to a lecture by a couple of biologists who did experiments in New Zealand next to one of the hot springs. And the experiment showed that you could actually create life provided you've got tides coming in and out. So the effect that the moon has had on the Earth goes far beyond looking pretty and helping us to navigate at night.
Thank you, Tibor. And thank you for everyone who's just joined. Just to let you know, we're advertised to finish at 9:30, but we will finish at 9 because that's when the action starts in the sky. Everyone is very welcome to chip in. So please don't feel shy about unmuting yourself and asking a question or making a comment. We really want this to be very interactive and a big old chat. So please don't feel shy. Let's kick off with, and if you have questions you don't want to voice, either send them through on the chat or to me or everyone, and we'll pick that up as we go through. So let's kick off with a little poll here very quickly. See who can get this right, and then we'll talk a little bit about what we're actually going to see in the sky at 9 o'clock. I should say that if you fail this, you get kicked off immediately, so the stakes are pretty high.
That's rather draconian.
I know
It's anonymous though, right?
it is anonymous.
Anonymous.
Yeah. Actually, I don't know who it is, so.
I've got a protest here for a second. You didn't have ACT as one of the
I know
for locations.
No, that was absolutely deliberate, just to make everyone feel a little bit superior to me. I made that mistake.
All right. Well, if I go about 2 kilometers up the road, I'll be in New South Wales. So how about that?
We'll see you in a couple of minutes then.
Yeah, I'm going to admit I'm multitasking. I've got my infrared converted camera with the lens set up outside, and I'm just looking at the early shots that I'm getting. So
okay.
At the risk of hijacking a second, I'm a former naval officer turned industry turned academic, and I am old enough that I was taught to navigate with a sextant and can do reduction of sun, moon, stars and MER passes by first principles. And certainly I was always happy when I had a moon that I could do during the day to be able to do a moon, sun, and almost get a 3-point astrofix by day.
That is awesome.
Thank
you very much for sharing that, Amanda.
Many of us like that left.
It's actually coming back. So I was approached to do some reserve time. I'm not a specialist navigator. I'm more in the int and communications world of Navy, but they were looking for more people. Hello, Laura Maynard. they were looking for people who actually are qualified as to do astronavigation, to be able to teach people. And I once had to go to court to explain how I knew precisely where the specific vessel that I had boarded was. And the judge was again quite fascinated by the fact that I had taken a sun site to calibrate all our GPS units. So even knowing about the orbitography of the Cospas-Sarsat network, which was one of my day jobs for a while, I still do look up to look at the moon. And that's from last month, taken just up, if people know Canberra, in the Mulligan's Flat Sanctuary. So I'm just looking at what we've got coming up next.
Fantastic, thank you. So the polls in, and the consensus here is that the Earth blocks the sunlight. So I think that's correct. Would anyone on the panel or anyone else like to describe what we're actually going to be seeing this evening?
Well, Geraint's the man. Let me just add that peak red moon, peak blood moon, is at 9:18 p.m. Sydney time.
Okay.
Okay, I can do the astronomy part. I should point out that astronomers don't use phrases like pink blood, werewolf, flower moon, and all these other things that go around in the media. For us, of course, it's the physics that's involved. And what we've got, of course, is we have an alignment of the sun and the earth and the moon. And in that alignment, the earth is blocking the light of the sun and so casting a shadow, and the earth is moving, the moon is moving through that shadow. And so we're seeing the moon go dark as it enters the shadow and travels through the shadow. Importantly for tonight, when we get totality, there is still some sunlight getting to the moon, and that sunlight is being refracted through the Earth's atmosphere. So in just the same way as the sun appears red in the sunset, the light that comes through our atmosphere and then arrives at the moon after being refracted, that's had most of the blue light scattered out, and the moon takes on this red kind of hue. I think one of the interesting things, which is I often get asked, is about why we don't get this every single month. Why don't we get a lunar eclipse each month when the moon is behind the Earth and the sun is in front of the Earth? And what people don't realize is that the actual universe is kind of messy. So the orbit of the moon is sort of tilted to the plane of the orbit of the Earth. And so because of that tilt, often the moon is behind us and still getting illuminated by the sun. It doesn't enter the shadow. So it takes a particular kind of alignment, which astronomers have calculated, I think for, I won't say thousands of years. People see these cycles, they work out when these cycles are going to occur. So we're just seeing the next step in the cycle of the moon moving through the Earth's shadow, and we'll get to see the blood red moon as well.
And I think if I can just add in there, one other thing that's going to make this quite a super moon is that the moon is in its perigee, which means that it's actually closest to the Earth in its elliptical orbit. So that's why it's going to seem really big. And yeah. Oh my goodness, is that right now, Amanda?
So I'm going to admit to something. That was about 12 minutes
Amanda's
ago.
background just changed.
Yep. So it's 12 minutes ago, but it's taken with
that's amazing.
A camera that's been infrared corrected. It's had its filter removed, and it's at 590 Newton for those people who understand the infrared spectrum. So I use it a lot when I'm close to a city because it does cancel out the local light. I've got about 21 photos from the last 12 minutes, and yeah, that's the bite coming out. So I'm looking forward to going back out there. The camera's poised, ready to go.
Very nice.
Great, thank you. A question's come through from Peter. Hi, Peter. Thanks for joining. What is the frequency of the cycle? I presume, do you mean the moon going around the Earth?
Well, the moon around the Earth is the easy one, right? That's 28 point something days, regular as clockwork. I cannot remember the precise cycles for the various eclipses because there are different kinds of eclipse. So you either have a total eclipse where the moon is completely in the Earth's shadow. You get partial eclipses when it just cuts the shadow. And I do not remember exactly what the cycle is, but it's not an overly rare event to get a total eclipse of the moon. And as Kirrily noted, tonight is a special one because the moon is particularly close so it would look large on the sky. Although I have always struggled to see the size difference of the moon when it's at perigee and apogee, because its orbit is relatively circular.
So does the moon, I mean, are there different degrees of total eclipse? I mean, because we've got a big shadow, right? And the moon is much smaller than the Earth, so.
Yes. Yeah, so if you think about the moon's orbit is tilted with regards to the Earth's shadow. And so you could actually just get an eclipse where the moon just clips the Earth's shadow. And so you just lose a little bit. Nobody cares about those. You can get lots of partial lunar eclipses when just a bit of the moon goes. It seems like most people aren't that interested in those either. It's the total eclipses that matter. As I said, the shadow is quite big, and you can tell that by the fact that the entire process of the lunar eclipse is quite long, right? It's over a period of like 40 odd minutes, I think, is the total tonight. Whereas for the shadow of the moon on the Earth, that's only matters of minutes.
Got you. Right. Yeah, that makes sense. Does anyone have any other questions about what's going to happen tonight?
Oh, and werewolves. Don't forget, there's werewolves tonight as well.
Were-wombats.
And werewolves.
Were-wombats. You've got
Drop
to
bears.
watch out.
Well, let's move on to
lunatics.
Exactly.
to the origin of the moon and have a little bit of a chat about that. I saw some information coming around today that it's and I had no idea about this, that there's some chunk of something that hit the Earth and spat a bit out. Is that roughly right? About 4 billion years ago?
Should I be the astronomer again? So the question of why the moon is so large, means that people have had to think really hard about what's the origin of the moon. As I said, if you look at lots of moons in the solar system, like for Mars, they're really small rocks which could have just been captured. But for the moon, they think it was a much more traumatic event. So just after the solar system formed, roughly 4.5 billion years ago, the planets were still forming. There was lots of rock and debris still floating around. And the Earth looks like it was struck by a lump of rock, effectively another planet, roughly the size of Mars, which is known as Theia. That collision basically completely vaporized that planet and tore a huge chunk out of the proto-Earth. That debris all got spat out, but still got held by the gravitational pull of the Earth, and then recondensed down to be the moon that we see today. And we sort of know this because the Apollo astronauts brought rock back from the moon and basically found Earth rock. So they found that the moon itself is made of really old Earth rock.
Okay, good. Anyone, please jump in and ask any questions.
Yeah, can I just ask a question?
Yeah.
My name's Neil. I'm friends with Geraint. I sort of chase him around every couple of weeks and we exchange astrophysics for finance. We've sort of got a fairly good friendship going. So he just invited me tonight. I just want to ask a question. I'm not sure if it's for him or maybe someone else. When Neil Armstrong was, I think, in transit to the moon, I think one of the sayings was that he was concerned what he was landing on. He didn't know how thick the regolith was. And I think in the back on ground, they just made it up and said 2 or 3 inches it's safe. Is there any scientific process to actually know how thick that regolith would be without having landed on the moon, and how safe it would have been to land?
I can jump in there again. Sorry, I feel like I'm taking over the entire thing, unless Kirrily or Tibor wants to jump in. I mean, the thing is that there were landers on the moon before people got there, right? The Americans definitely got some surveyor probes down before Apollo got there, and they found that it just landed and it was fine. So I think they knew beforehand that there wasn't really any risk of there being this planet-wide thick regolith. I think the worry was that if you were in a depression where that stuff could have built up, that could have been problematic. But I think overall, I think they were reasonably confident as if they chose a reasonably flat area, it should be okay.
Thank you. Does anyone know whether they had any problems with machinery? Because
Very definitely did.
they did, because it's really spiky stuff, isn't it? The regolith.
Yes.
Yeah.
So I spent 2.5 years working at Northrop Grumman. I was in LA at Space Park, and I had the privilege of meeting Buzz Aldrin while I was there.
Wow.
And Grumman side of the house, if you're familiar with Apollo 13, the Grumman team are the ones who built the LEM and were doing the calculations about how to get the air filters to work. They still tell stories about how pervasive the grit from the regolith was, and there's that great engineering on the fly story. I think it was one of the last missions where they broke the fender on the Mars rover the buggy that they were getting around on. They tried driving it without the rover, but the amount of kickback coming from the vehicle's wheels was just completely shredding the vehicle itself and contaminating so many other sensors. So that's why they had to improvise with a replacement fender, and they actually still have that fender. If you go to the Smithsonian, it's there, and they explain it's the big Smithsonian for air and space science out near the airport rather than the one in DC. So the challenges of dust proofing or moon proofing equipment has always been a challenge for the teams who've been involved with it.
Great. Yeah. And of course, the reason for that for everyone else is that it stopped moving around. So there's no sort of erosion that rounds all the edges off, so that it's a very fine, spiky powder that gets everywhere. And I think it's probably electrostatic as well.
I have heard it likened to when you get liquefaction around an earthquake zone, that kind of porosity and viscosity that you get is actually quite similar.
Okay.
And would it be similar on the surface of Mars? I know we're talking about the moon, but I just wonder if other surfaces haven't got the same problems.
So my understanding is that the Victorian Space Centre with the Mars experience for teachers, the surface that they have put there is actually very, very similar to, they've replicated it very well in terms of quite a significant level of compaction. And then the loose scoria, the boulders, are very much like the Gibbers Desert. So it's a different surface and terrain, and it's actually quite varied as well, as my understanding.
Okay. Mm-hmm. Now I'm a bit behind the times here, but let me, for the benefit of those who don't know, let me show you the geometry of how the moon goes. I don't know if you can see that.
Yeah, it's coming through.
Okay, good. That shows you just how irregular and how random the whole thing is. Geraint's absolutely right. Nothing happens in a straight line on the moon or on the Earth or anywhere in space. You can see every orbit of everything is inclined to everything else. The whole solar system is riding like a pony on a carousel around the galaxy. It goes around once every 200 and something million years. The solar system itself is inclined at an angle of 60.2 degrees that you can see there. The Earth is inclined to that. The moon is inclined to that, which means the whole thing is all over the place. And if you track the moon in the sky, it's basically just about every time it goes around, it's in a slightly different position. I think Geraint, we get eclipses in pairs because the difference is only a 5-degree angle. And if it happens once, and the next time around, it's kind of close enough to happen again. And then you don't get one for a couple of years while the orbit goes out of alignment. But usually we get pairs of eclipses together, maybe months apart, and then none for 2 or 3 years or something is the pattern for, as I understand it.
Yeah, I said I can't remember exactly what the frequency is. You need a proper astronomer who actually looks at the sky. Can I also add to this picture, one thing that that people don't realize is you mentioned that the solar system goes around the center of the Milky Way galaxy, and it goes around about once every 250 million years. So we are now where we were when dinosaurs basically first arose on the Earth. the other thing that happens is that the solar system actually bobs up and down as it travels around the solar system. So it is really like a carrot sitting on a carousel horse. It goes up and down and passes through the plane of the solar of the galaxy. And it's thought that sometimes these passages might be a cause of mass extinction on Earth, because the comets in the distant solar system get shaken and can rain down on the inner solar system. So it's very complicated motion.
Yeah, and the other thing that we do is we move in and out of the arms of the galaxy. So we move through more dense clouds of cosmic material, and then we move into more sparsely dense material. At the moment, I think we're just going into one of the clouds, and some of the climate change people are using this, some of the climate change skeptics are using this as an excuse and say, look, it's the fact that we're moving into this cosmic cloud and all this cosmic radiation is causing the global warming. And no, it's got nothing to do with the 10 billion tons of carbon that we pump into the atmosphere every year, which of course is not quite right, but that's a story they use. So yeah, all sorts of funny things happen as we go around the galaxy and as everything goes around everything else.
So one thing that intrigues me is about the moon is that it sort of rotates at the same speed, so that we it always shows us the same face. Is that something that's unusual, and how did that happen? Has anyone got any ideas about that?
That's actually quite common, I think.
Is it?
Yes, it happens. What happens is it gets captured, the rotation gets captured. Mercury, for example, shows the same face to the sun. It's
No,
also captured.
That's not true.
Isn't it? I thought it was. I thought it's...
Mercury's in a resonance with Venus, but it's along the same lines.
Okay.
Right? Yeah. So again, what's happened is that the moon and the Earth aren't perfectly spherical. They are somewhat distorted, and those distortions basically act on each other. These are tidal forces that they experience from each other, and the tidal forces act to bring the orientation of the two rotating objects down to their sort of lowest energy. So for the moon, what's happened, it's become tidally locked with its face towards, same face towards the Earth. And if you get any close pair of objects that aren't perfect spheres, they will eventually, their rotations will be coupled such that they eventually have the same face facing each other. So it's
basically like when I'm balancing my motorbike wheel and the heavy bit goes downwards. Yeah. And it doesn't, it always will be as it goes around the Earth.
Yeah.
Okay, good. Thank you. The polling for the result about the density of the moon is correct. It's a little bit lower than Earth. I think 3 instead of 4. I forget the units now. Okay.
That's partly because it hasn't got a heavy iron core at the center the way the Earth does, or at least it's got a much smaller one if it has any at all.
Yeah, much smaller, more compact core.
I'd imagine the larger that bodies get, the more dense they become anyway, roughly speaking. Would that be true?
No, because Saturn is less than the density of water.
Yep.
Okay.
The gas giants.
Yeah.
Okay.
Then you go to the Jupiter. You go further out.
Yeah.
What's the density of Venus like? Does anybody know?
Venus is, I think, very similar to the Earth.
Okay.
It's a very, very similar planet that but it's a similar planet, but it's freakily different in that it seems to have lost its geology and lost its magnetic field, and we don't really know why.
Yeah, it doesn't rotate on its side as well?
No, Neptune's on a side.
Or is that?
Yeah, Neptune does that.
Okay, it's Neptune.
Venus is upside down. It rotates in the wrong direction.
Right, that's it. Yes, I knew it had a strange, yeah.
And a very slow rotation, so 240 odd days, I think, to rotate. But we're not talking about Venus tonight. We're talking about the moon.
We're not.
Are there any other questions about the moon itself or how it came into being?
Well, let me ask a question about the moon. If the moon is facing us and it has the same face facing us, then presumably to some small extent, the gravitational pull on the front of the moon by the Earth is greater than the gravitational pull on the back of the Earth. Oh, sorry, on the back of the moon. So I know that I've heard about how Jupiter and Saturn actually massage their moons. They kind of knead them and warm them up by a gravitational kneading as the moon turns. If ours is not turning, does that now mean that the moon is somehow slightly lozenge shaped, or has it got a pointy nose that points a little bit towards the Earth or something? Has it actually affected the shape of the moon that's in a non-uniform gravitational field, or is that effect weak?
The Earth is egg-shaped, I read, but I didn't know which came first, the lack of rotation or the egg.
The Earth is flat. The Earth is it's flattened at the top and bottom. It's about 50 kilometers wider around the equator. It's kind of pregnant, but it's not egg-shaped.
I meant the moon is egg-shaped.
Is the moon egg-shaped?
I read the moon is egg-shaped to some extent. Yeah.
If the moon was perfectly spherical, it wouldn't become locked. And the Earth is still responding to the moon's gravitational field, not only with tides in the water, but also tides in the crust. So the crust itself actually rises and falls every day as the moon passes overhead.
Actually, I've heard that. I've heard the people at the LHC have a problem because they have to adjust the length of the 27-kilometer ring according to the phases of the moon. So yes, I understand that does happen.
But even the moon's crust is thinner on our near side than it is on the far side. And I was reading one article that said, during the formation of it, the Earth was still a proto-Earth. It was still quite hot and molten, and that it cooked the moon, the near side of the moon. And so that's why it's much thinner, the crust on our side than the other side.
Right, okay.
Why don't we move on and have a little talk now about colonization of the moon. Let's start with a poll and see who knows the answer to how many lunatics there have been so far. Not including.
What if the number isn't there?
Yes, that's what I was just thinking. Thank you, Kirrily.
That's okay, Amanda.
I was doing the math.
Yeah, hang on.
Well,
do you underestimate or do you overestimate?
I did strive to put the right answer there, but I don't have 100% success on getting the answers correct this evening, so it could happen again.
Amanda, I'm going to message you what I think the value should be.
Yeah, I heard it is 17.
Well, I stole this from various quizzes online. And
Scott, I didn't see number 17. I thought it was 17.
Well, if you have a look on the
anyway.
NASA website, I'll see if I can bring up the NASA website real quick. It's got this lovely little graphic that tells you how many people have been there, how many people have walked on the moon, how many robot visitors have been there. Hang on.
Yeah, maybe I should have said walked on the moon.
Yeah.
So it's 12.
That's what I meant.
12 walked on the moon.
That is a different, again, my office in Redondo Space Park, the James Webb Space Telescope was 3 down from us, and NASA JPL and some of the other buildings were there, and they actually had the photos of everybody and the Apollo crew who was lost, which is quite a poignant moment, but they're there as well. So, yeah.
So there are there are 10 people who are very good and understood the question as I meant to ask it.
Yeah, but 24 people have actually been to the moon, but no women yet.
Yeah, so that is why the first woman is 2024.
Apparently.
Yes.
Apparently.
Going to be.
You think?
The NASA is sending the woman to the moon next mission, NASA mission in 2024. That is what
wow, that's
NASA
only 2 years away.
I know.
Yeah.
I wonder how much COVID and international travel restrictions are going to knock that out of the ballpark.
They don't have
there is
COVID on the moon. It's okay.
Probably the safe place to go. Yeah.
Yeah, but the astronauts still have to be 1.5 meters apart.
Yeah, exactly.
Oh, that's right. Yes, they do. They do. Yeah. So, I mean, colonizing the moon is a fascinating idea. Yeah, I think NASA has committed to 2024. They're going to send another group to the moon. With 2028, they're going to have a lunar space station that they're going to call Gateway, that they're going to install at the moon. And the current landing site they're looking at is close to the poles, where there's likely to be a lot of frozen water. So yeah, choosing the correct landing site is key. I mean, there's so many challenges that these people are going to face when they get to the moon. They've got a lot of answers to try and get through before they send them up. You know, things like the dust that Amanda mentioned before, even the temperature. I mean, you know, the temperature varies on the moon depending whether it's in the light or in the dark by such a great amount. You know, when the sun is shining on the moon, it can get up to 127 degrees Celsius. And when the sun is not shining on the moon, it can get to minus 230 Celsius. That's 40 Kelvin. I mean, that's just the temperature differences are phenomenal. But they're just two things that are going to be quite challenging for anybody trying to live on the moon.
So here's another.
I think you're going to find the very sad thing is that the post-COVID austerity of budgets are going to hit very hard on scientific research. I'd really be surprised if NASA maintains its funding, and I think the next 5 years you're going to find some of the payback from the stimulus is going to probably slow down a lot of these programs. It's pretty sad. I was talking to Geraint about it a few weeks ago. And I think research and exploration are going to be two of the casualties.
I think the wild card though is still China. I think so. China is pushing their program forward. So if NASA doesn't step up, I think they could find themselves in another space race. But you're right. I mean, it doesn't seem to be a huge appetite for space travel at the moment.
But I mean, you imagine the whole space race and how much new technology has come out from trying to answer, you know, the challenges of space travel. You know, technologies that we now use on Earth. For the human race, I think a space race is a great idea. You know, it generates more ideas, novel ways to solve problems, new technologies.
If you think of another very upsetting statistic, in the last 12 months, the total global stimulus for COVID has been about $12 trillion US. 1 trillion probably would have a complete colony on the moon and on Mars. Just a 12th of what they spent in the last year. It's pretty sad.
If you can pause for a moment and consider the idea that we've actually flown on Mars as opposed to flying on the moon, the concept of having a UAS be able to take off from the Mars rover and continue. I did a master's in global project management. We were talking about geographically diverse and dispersed teams, how you deal with different time zones. And I pointed out the next generation of project management, we will have to look at people beyond the ISS, because that's already been an issue, how you deal with people who don't have a day and a night. But what are we going to do with people who are on a different planet that you can't celebrate the end of a project because they're, you know, you can't just send them a cake or order pizza when they're working late. It's going to be a fascinating, whether we've got the moon base or we've got Mars base, and this idea of, is it Mars 2030, Mars 2025? They're very keen on having that different planetary approach they can develop.
Interestingly, I learned today or yesterday, the moon has its own time zone, which is...
Does it?
It does, yeah. Just one.
Central moon time.
So, yeah.
Central moon time, I love it.
That's a great idea.
What about the billionaires? I mean, the point that was it Neil made about nations not funding this. I mean, Mars is obviously being pushed by Elon, and will the moon feature in that, or is it just not
Space tourism.
gnarly enough?
Yep.
Well, it's quite interesting. I was looking up space tourism. There's a couple of companies that sort of came up, and then some of them crashed, and some of them have come up again. You know, there's two types of lunar mission that you can, or tourism that you can take. You can just do a flyby, or you can actually have a lunar landing, and the costs that are quoted online for these are very different. So if you wanted to do a lunar flyby, that's going to set you back $150 million. But if you want to actually land on the moon, it's $750 million. So I don't know exactly, this is US dollars. I don't know exactly where these figures are coming from and how many people, you know, do you have to fill up all the seats on your rocket to make it viable?
Yeah, so my understanding is that Elon Musk is flying to Mars, not to Moon. And he's taking bookings for the Mars, not to a moon.
That's right. And Virgin is pushing the moon idea.
Yes,
I think
so
Jacob,
the first colonization can be on the moon, on the Mars. That is what Elon Musk and Jeff Bezos is pushing.
Yeah, I think Jacob, one of the biggest problems I think for reaching Mars and colonizing Mars is certainly the radiation. You know, the radiation damage for the amount of time it's going to take these people to first travel there. It takes a couple of years, then to set up a base, and then to travel back. They'd be dead before they get back with the current technologies that we have for radiation protection. And in fact, there's a lot of universities now that are doing research into different materials and different sort of ways to stack materials that will better protect people from radiation. I mean, even on the moon has, if you're standing on the moon, you're receiving 100 times more ionizing radiation than you would be if you're on the Earth. So to give you another idea, if you flew from Sydney to Perth, which is a 5-hour flight, that's how much radiation you would get by standing on the moon for 1 hour.
Oh, the women in physics lecturer of the AIP gave a talk in lots of talks in New South Wales recently, and she took that's what she was talking about, the radiation. Interestingly, though, they've done some measurements using moon regolith, and you only need about 1 meter thick in order to make it doable. So it means that the moon could be a good staging post. You could take up your sort of your bare spacecraft up to the moon, and then you could just encrust it with regolith, so that taking you're blasting soil up into space or whatever, concrete instead would be very costly, but getting it from the moon might help solve some of those issues.
Yes, even on the space station, the astronauts have to wear radiation meters the same way as people down here wear around nuclear reactors and so on. And if there is a solar gamma ray burst, which we can detect now because we've got satellites looking for them, the people on the space station go scurrying into the Soyuz box or something, try and get into somewhere where it's more shielded. Because if they stayed in the general area, they'd fry. They literally would be killed by the amount of radiation out of a massive solar burst. So the radiation is really quite hostile. And we're protected down here on the Earth because we're blessed with a nice atmosphere that with a big ozone layer and some ionization.
And a magnetic field.
And a magnetic field, that's right. So that filters out much of that radiation. So all we get is a bit of sunburn. But if you're on the moon with no atmosphere, you get it's like you're standing in front of an X-ray machine non-stop. It's very, very strong radiation.
And I think one other thing about sort of long-term colonization of the moon is trying to consider the solar activity cycle. So the solar activity cycle is something like, I I think 11 or 12 years. So it goes through a minimum where, as I said, the radiation is about 100 times what you would get on Earth. But then it goes into its maximum where it goes orders of magnitude greater than this even. And I mean, that is the period of time when it would be dangerous to be in the in a colony on the moon. I'd say you'd want to get more than a meter below the regolith then. Dig deep.
You certainly want to have an umbrella. There's no
yes.
doubt.
Mm-hmm.
Hey, Kirrily, can I ask you?
Yeah.
You're probably a little bit young to remember one of my favourite space series, Space 1999.
Oh, I love that.
No, I don't know it. Sorry.
Eagle One. Some of the other people have seen that. To put a space station, a space colony on the moon, is there actually anything to mine there? Is it self-sustaining? Is there hydrogen in the soil? Is there?
Yeah.
Is there,
absolutely.
Yeah.
That's a really good question, Neil. Absolutely. There's got to be a good motivation to go to the moon, not just because we can.
Yeah.
So the moon's really rich. It's got a lot of resources. Helium-3 is one of the resources that people think that we can mine from the moon. Now, helium-3 is quite rare and hard to come by, very expensive on the Earth, but we can use helium-3 in fission reactors. So it's not radioactive, in fusion reactors, beg your pardon. It's not radioactive. It wouldn't produce dangerous waste products. So helium-3 is a big one. Another big one is there's ideas of, as I said, there's water near the poles, sort of frozen water near the poles. And if we could split the water into hydrogen and oxygen, suddenly we've got fuel, rocket fuel. We can, use our hydrogen fuel to start producing, exactly, it's rocket fuel. So if we want to start from the moon and then get to Mars, we can collect our fuel by splitting the water into hydrogen and oxygen. There's also a lot of minerals on the moon, rare earth minerals. While we do have some quite a fair bit of rare earth minerals on Earth, they're hard to come by, and the monopoly is held quite securely by China for the rare earths. Now, rare earth materials are materials that we find in a lot of our technologies, in sensors and things in your mobile phone, for example. So for the technologies that we're designing now and designing for the future, rare earths are going to play a really large role. But of course, we've got limited resources here and we can find them there. But even things like transition metal ions like iron and these sorts of things we could probably get from the moon as well. So I think mining would be a big industry that we would set up on the moon. But of course, we have to do this sustainably. That's one thing that's in the Artemis Accord at the moment, or the Artemis, is it the Artemis Accord? I think it is. Is that what it's called? I can't remember. Where it sort of outlines who can mine, who can go in there, how much is going to work sustainably. Something that the whole world, it's a global issue to consider.
Yeah. I think there should be an international law. There are some space lawyers working on that, but recently the US government have some rulings on that. Who can do all these activities on who owns? If you land, whether you can put a flag only or you can own that. That is the question mark, which is not answered so far, I understand.
Yep.
What you told is true. The helium-3 is the biggest source for energy. It can solve our energy problems, and you have to try out how you can bring it back to Earth. That is one of the biggest challenges.
That's exactly right. That is a good point.
So how much helium-3 would you need to bring back to make a fusion reactor?
Not a huge amount.
Really?
No. Yeah, so I can also add another reason why you'd want to colonize the moon is that if you do have all your resources there, all your stuff for making metals and fuels, it's much easier to launch spacecraft from the moon. So using it as a stepping stone to Mars is much easier than trying to get to Mars in one shot from Earth, because getting off the Earth is the most expensive part.
Yes, that is one of the motivation why to land on the moon again, because we can build rockets and we can fly to Mars from there. We can have shuttle flights from Mars from Moon. It is rather more economical to fly to Mars from Moon, because you get the abundance of fuel, and you can have the rockets made over there with 3D printing. People are trying to do 3D printing on the moon, so they can 3D printing food is already happened. KFC has already done that demonstration of the 3D printing in space station. So that is what is proposed to do on the moon also. So things are all looking. That is why people are telling 20 years they can colonize moon, but I expect that will be too short a time.
What are we going to do about an atmosphere? I know we're going to live in a bubble, that's fine, but even in a bubble, we have to manufacture breathable oxygen, and maybe you can't have pure oxygen, that doesn't work. You've got to have it about 20%. You need either nitrogen or helium or something as a filler. Where are we going to get the oxygen from to create an atmosphere that a permanent base station on the moon can breathe? Does anyone know?
Well, I presume if you've got water, then you split the water and just chuck away the hydrogen.
Well, use the hydrogen for your rocket fuel, and then keep the oxygen to breathe.
So is the hydrogen in use without the oxygen as a fuel?
There are hydrogen fuels which come in a gel form, which are self-sustaining without oxygen.
Oh, is that right?
Okay.
So to answer Tibor, just got here the composition of the lunar soil. 45% is silica, which is SiO2.
All right, okay.
And then alumina, and then lime, and then iron oxide. So there's plenty of oxygen. I think you're going to struggle to find nitrogen, but there's plenty of oxygen.
Okay.
Yeah.
I mean, the simple thing would be to, I'm not saying simple, but the more straightforward approach would be to build a habitat which you can then have environmentally controlled, rather than try and repopulate the entire atmospheric conditions, because it will boil off that quickly. But fascinating kind of challenge to have to deal with. Maybe there's sorry, Kirrily. I was going to say maybe there's a biological solution, some kind of plant form that can be grown which can generate oxygen. Lord knows it'll have enough solar power to keep it chlorophylled and be able to conduct that phytogenesis type approach.
Well, there's plenty of sun, so solar power won't be a problem. Other than, of course, we have to make sure the solar panels can withstand the temperature difference of minus 200 and something and plus 100 and something. It's going to have to be a pretty robust solar panel.
There already are solar panels. You see them on the ISS every time they come over. They've been up there for years.
Does the surface of the ISS get just as hot and just as cold?
Yeah.
Okay.
Yeah.
What part will robots play? I mean, by the time that we're all ready to make a colony, the robots will be so far advanced, then you'd be using them, to a great degree, so much so that you might as well stay at home and just use the robots. The only difference is that you can be closer, and so there wouldn't be much lag time between when you say something, you want to bark out a command and it happens, But because you just think that even if you were stuck inside your little bubble and you wanted to go and have a look over there, you wouldn't walk outside your bubble because it'd be just too much trouble. You would get a little robot that would go and have a look. So you might as well be at home and just get the, I mean, look, Tibor's on Mars at the moment. Now, if he wants to go walking in his backyard there, he wouldn't. He would just send out a robot. Well, we're doing that already, So, and like I know somebody who works with underwater robots to do mineral exploration. So they develop different things that they can go very deep that you wouldn't be able to, breathe in, and or you'd be squashed to smithereens. But they send a robot down to do mineral and oil exploration on the bottom of the ocean. Well, they're robots that have to kind of think for themselves a little bit, you would do, I mean, and we are doing the same with exploration. So they're going to take up a lot of the work that we were talking about, aren't they?
Absolutely, and they should. Yeah. You know, but robots are tougher than us, but they're not infallible. You know, you look at how much the space dust or the moon dust is going to clog up their moving parts. So, you know, that's something that we have to address. You know, even the electronics on these robots are going to be affected by radiation. Certainly, I work at ANSTO, the Australian Nuclear Science Technology Organisation, the nuclear facility in Sydney. And, you know, we see that some of our electronic components are, if we put them in our neutron beam, they die, you know, they're strongly affected by radiation. So, you know, we can't think that robots are invincible. Yes, we should make them do the dangerous jobs, but yeah, maybe it needs to be a combined effort, Peter. I think you're right there. Maybe a combined effort of humans with their robot helpers.
I think the question is, if you ask, will robots go? Well, you know, they're already going and they always will. I think the other question is, will humans go? And and if we do go, then we'll definitely be accompanied by robots, I think. So, yeah.
I think it depends what our goal is. And I think eventually we're going to get to the point where we realize we can't, you know, Earth has got a finite lifetime. In 1 billion years, and I know 1 billion years is a long time, but for a cosmologist, it's not. 1 billion years, the sun will have gotten so hot that it'll be impossible to have life on Earth. So that's the time we've got, and as all good humans, we'll leave it until the last 5 minutes. But Earth only has a finite lifespan.
And we'll leave robots at home to fight the wars that we fight all the time.
Well, we are just the digital bootloader for the the biological bootloader for the digital superintelligence, right? So. Yeah. The moon is going to start happening soon, and so I suggest we switch off this and
we all run outside.
Go and have a look outside. Let me just thank our panelists again, Kirrily, Tibor, and Geraint, and a big thank you also to Amanda, who has contributed such a lot to the discussion tonight and contributed those amazing photographs. She's shared it on the chat if you would like to download that, which is awesome. And I think Amanda will probably be able to navigate herself outside and find the moon for sure. So let me just give a plug for the AIP and the Australian Institute of Physics, who have organized this, and this is a monthly get together. And we have decided to do the next one. I think, is it 23rd of June, 8 p.m.
Correct.
And the topic for that one is power. We've touched on that a little bit today with helium-3. So check the usual channels, and information about that will be coming out pretty soon.
We should clarify power in a physics sense rather than power in a world domination sense.
Oh, I don't know.
Yes.
No politics, please.
Energy.
We're
what if we say energy?
Yeah.
Everything's energy, right?
Yeah.
In my world, everything is energy.
Well, I think with physicists involved, I think you know, if we have a mad physicist who wants to take over the world, I think that'll be within scope. Just not politicians. All right. Thank you, everyone. Thank you very much for attending. I hope you enjoyed it. I certainly did, and I'm sure the panelists did as well. Go and enjoy the moon.
Thanks, everybody.
Thank you, everybody.
Bye.
Thank you, Amanda. Thanks, everybody. Okay.